of a triangle, we need to just add all three sides together. So we get a plus 1 over 6. We get a plus 2 over 3. And then we get a minus 2 over 4. The common denominator between 6, 3, and 4 will be 12. So you need to change everything into 12s. You need to multiply the 6 by 2. So you need to multiply the top by 2. You need to multiply the 3 by 4. You need to multiply the top by 4. And then remember, you're multiplying both parts. And then the last part, you need to multiply both parts by 3. So what we're going to get is we're going to get 2a plus 2, is it? Over 12. Then we're going to get 4a plus 8. Once again, all over 12. And then we're going to get 3a minus 6 all over 12. Then we're going to add all the a's together. 2a plus 4a. 6a plus 3a. 9a. 2 plus 8. 10. 10 take away 6. 9a plus 4 over 12. Alright guys, so here we go. Anytime two fractions have the same denominator, does everybody know the answer for 2 over 3 plus 5 over 3? So once the denominator is the same, just add them. Agreed? So what do you think about 22 part A? What do you know about the denominator? So how'd you do this question then? 3 take away 2? 1 over x minus 1. That first question was handy, wasn't it? Now, the second question, not so handy, okay? Now, there is a fancy way of doing it, but I am sure you'll spot it in an exam. So, if you look at question 2 is a bit cheap, and I'll explain why. Do you see the way the first denominator is twice as big as the second denominator? So what'd be a really cheap way of doing this? Actually, oddly enough, you could half the first one. You're not wrong, because it's even top and bottom. But I'd be more inclined to multiply the second one by 2 top and bottom. And what happens here? 2 over 4x minus 2 take away. Oh, take away 2 over. Now that the denominators are the same, 2 take away 2. Doesn't matter what the denominator is if you have 0. 0, 0, no matter what you're dividing it by. 0 divided by 100 is 0. 0 divided by 2 is also 0. So you can just write down 0. Now here's where things get a bit difficult, okay? And we'll try and make this as easy as possible for you, okay? So, do you guys remember when you're adding two fractions that have different denominators? So, classic example would be 3/5 and 4/7. Okay? All you need to do is, denominators are like children. They want what the other one has. So this one has a 5, and what does it see the other one playing with? A 7. It goes, I want a 7. I go, here, you can have a 7. But you also need a 7 on top. What does this one want? And if it has a 5 on the bottom, it has a 5 on the top. And what you get here? 21 plus what? Plus 20 over 35, which is 41 over 35. Yeah, happy enough with that? Now, I want you to apply the same logic you just did there a minute ago to part C. So, here's what I'd like you to do with part C. Once my program stops glitching on me, right? So, what I'd like you to do is this. It's 3 over x minus 2 plus 1 over 2x minus 1. And what we're saying is, what does that one see? So you're going to do 2x minus 1, top and bottom. Now you guys now what you get here? 6x minus 3, yeah. And the other one? No, just x, isn't it? X minus 2. The bottom is the same, so we can just put one bottom in, can't we? And then the answer, 5x minus 5 all over. Oh, sorry, 7x. Sorry, not 5. It's not 5x, it's 7x. So 7x take away 5, yeah? And then x minus 2 and 2x minus 1. Will you guys start 23A? So you do the same thing top and bottom. Alright, I'm going to do the first one then. 3x minus 3 on top. And then minus 2x minus 2 also on top. And then your x plus 1 and your x minus 1 on the bottom. Either order, it could be x minus 1, x plus 1. And then 3x take x is 1x. We've got x minus 5. All divided by x plus 1, x minus 1. Okay, that's the first one done, okay? Now you guys are on B and C. Option B. Same thing again. Gotta make both bottoms the same. 2x plus 1 here. 2x plus 1 here. And x minus 3 over here. And x minus 3 over here. And then you can finish. So 6x plus 3 on top. Because you multiply in by 3. 4x minus 12. All over x minus 3 and 2x plus 1. Did anybody get 10x minus 9? All over x minus 3 and 2x plus 1. They get pretty easy after a while, don't they? And then the last one. The last one is, I'll do really quickly. So we have 2 over 3x minus 1 plus 1 into 3x plus 1. Wrap it in brackets. And here we go. So what do we get here, guys? What? Just give me 1 sec. Yeah, 3x plus 1. 3x plus 1. 3x minus 1. 3x minus 1. I think I'm going to get 6x plus 2 on top here. And then I'm going to get 3x minus 1. All divided by 3x plus 1, 3x minus 1, or the other way around. Add them all together. 9x plus 1 on top. 3x plus 1 and 3x minus 1. And you're done.